In this video, I'm going to go over the hybridization in organic chemistry. So here we have two practice problems where we have to determine the hybridization of each atom that is pointed with the red arrow. So what hybridization is that if you have an atom that is attached to four different bonding groups, then that is going to be considered a sp3 hybridized atom. If an atom is attached to three different bonding groups, then that is considered to be a sp2 hybridized atom. And if an atom has two different bonding groups attached to it, then that is going to be considered an sp hybridized atom. So let's first start with this practice problem here with this first arrow. We know that this carbon here is neutral, which means that it has to have four bonds attached to it. We see 1, 2, 3 bonds to carbons, which means that the fourth bond is this invisible bond to hydrogen right there. Since we have four different bonding groups attached to this carbon here is going to be sp3 hybridized. So now let's look at this carbon over here. This carbon here is also neutral, which means that it has four bonds to it, where we see the four bonds to be here, 1, 2, 3, 4, which means that there are no invisible hydrogen bonds and there are going to be two different bonding groups, which is going to be this single bond and this triple bond right there. Those two bonding groups will make this carbon here sp hybridized. Okay, so for this next organic chemistry hybridization problem, we have this amine and this amide over here. Let's first focus on this nitrogen of this amine, where this nitrogen here has four different bonding groups attached to it. 1, 2, 3, 4. Three single bonds and one lone pair of electrons. This one lone pair of electrons would count as a bonding group as well. So since there are four different bonding groups attached to this nitrogen is going to be considered sp3 hybridized. Now let's look at this nitrogen of the amide over here. This nitrogen here looks like it has four different bonding groups attached to it, which is this lone pair, single bond, single bond, single bond, and it looks like sp3. However, this nitrogen here can do resonance with this carbonyl here, where this lone pair can move down there to make a double bond, and this double bond between carbon and oxygen will pop up onto this oxygen right here, which will give us this resonance structure over here, where we see this nitrogen is now positively charged with three bonding groups attached to it, which is going to be this single bond, and this double bond right there. Since there are three different bonding groups attached to this nitrogen, this right here would be considered sp2 hybridized nitrogen, because nitrogen would rather want to be in the sp3 hybridized form to allow for resonance over the sp3 nitrogen, because resonance increases the stability of compounds.